Last time on As the Ocean Churns. Heather realizes she's stuck in a grad school time warp, and Heather from Unsolved Science Mysteries comes by to help. Her alternative hypothesis gets destroyed while biofilm stays put on a couch symbolic of low-density polyethylene, and the pressure to come to conclusions is mounting. Will we ever get to the bottom of this? We'll have to. This is part 2 of the one-year special edition and the grand finale of As the Ocean Churns. Real question is whether or not biofilm is the reason metals are on the plastic. I can't prove anything. Nothing can be proven. Use evidence to support or refute your hypothesis. There's so much uncertainty. Uncertainty is part of life, and life is science. My experiments were imperfect. What if I did all this for nothing? There's no such thing as perfection. There's no such thing as nothing. This feels like an ending. It is an ending. It's also a beginning. I'm ready. What are you guys doing? Quorum sensing. Have you tried it? Oh, it's fabulous. Hey, look at you, conference pants. Why the business casual? I have results and conclusions. We looked at 3 materials in 2 locations. The Carquinez Strait at the California Maritime Academy, or CM for short, and the Romberg-Tiburon Center, or RTC. We can compare line graphs of all 3 materials from both locations that show biofilm amount or metal concentration on the vertical axis over time on the horizontal axis. We can also perform linear regressions and plot biofilm against metal concentration to see if we can make predictions about metals based on the amount of biofilm. The better the data fit the model line, the more likely the relationship isn't just random chance. We can look at the scatter plots side by side for each day that we sampled, and we can color code the different points to code for the different substrate types. Pink is glass, green is low-density polyethylene, blue is polylactic acid. And the different shapes will represent the 2 different materials. Triangles are California Maritime Academy, circles are Romberg-Tiburon Center. Remember, we measured biofilm indirectly by staining it purple and measuring how purple it was using a spectrophotometer. The resulting measurement is optical density. In both locations, biofilm grew best on low-density polyethylene, aka LDPE, one of the most common types of consumer plastics. Biofilm growth was similar on polylactic acid, or PLA, which is industrially compostable plastic, but if it ends up in the ocean instead of a composting plant, it behaves just like other types of plastic. For glass, the amount of biofilm depends on location, but it's a little dicey using this data because of our false positive on day 0. However, the dye's affinity for glass decreases once it's been in the water, and by day 14 it's staining biofilm nicely. So does biofilm influence metal sorption? Here's the answer. It all depends. It depends on the metal and the substrate and how long the substrate's been in the water. We measured high levels of zinc, calcium, and sodium on glass relative to the 2 other substrates. This might be because glass is a negatively charged surface, and that gives it an affinity with positive ions in the water. This would also explain why glass had an affinity for crystal violet dye. Crystal violet is a positively charged dye. That's why it sticks to negatively charged biofilm, which is why we use it in the first place. And it's one of the reasons why biofilm is good at sorbing metals. The positively charged metal ions in the water likely neutralize the negative surface charge of the glass, reducing the attraction between crystal violet and the dye once the beads had been in the bay for a while. So no supernatural biofilm. And I speculate that the loss of zinc over time that we see is because competing ions come along and replace it, or the biofilm is releasing it from the surface. Another thought is that maybe the metals are coming from the glass itself, but I think we'd see different metal patterns if that were the case. So zinc concentrations had more to do with the material than with the biofilm, because the biofilm was on all the material, but the zinc was mostly on glass. That's the case, it seems, for glass. But not necessarily the other materials. If we take out glass, we see a relationship between biofilm and zinc accumulation. Now let's look at aluminum. We see a similar but less pronounced affinity for aluminum on glass. However, after day 14, aluminum correlated with biofilm even on the glass. So in the first 2 weeks, even though plastic had more biofilm, it had less aluminum than glass. But after 2 weeks, the effect of biofilm surpassed the effect of the substrate, and biofilm became the best predictor of metals. Illuminating. For metals like copper, iron, lead, and nickel, biofilm on each bead is predictive of how much metal we'll find. It follows a linear pattern. The older the biofilm, the steeper the slope of the regression line. This hints that the metals are becoming more concentrated in the biofilm over time, which could be why after 2 weeks we had new metals like chromium and lithium show up that were previously below detection. Well, that's circumstantial. Correlation doesn't imply causation. Besides, look at how well iron predicts nickel concentration. How do you know that iron isn't the one attracting all the metals? If you had a nickel for every time you use that excuse, that would be ironic. Don't you think? Your silence is golden. Oh, no, that's silver. All I can do is present what I find and tell it the best way I know how. Okay, so what? The evidence supports the idea that biofilm is driving metal sorption on plastic, but it's possible that biofilm leads to metal sorption, which leads to more metal sorption. Still, my research shows that biofilm matters in this process. I'm important. I'm so happy. I'm crying. And I don't even have tear ducts. I don't think you're crying, biofilm. You're just mostly water. Well, looks like this mystery is solved. What will you do now? Write it up, hopefully publish it, move back to New England. I'll be looking for employment come the fall. I will miss it here. I wish I had a pair of ruby slippers to take me back and forth, but I just have these I got at Ross for Less. Forget ruby slippers, you need metal slippers. What about your grad school time work? If you could do it all again, would you? Oh yeah, well I'd find better ways of quantifying and characterizing the biofilm, maybe use molecular. No, I mean, if it could all happen again exactly the way it happened, would you do it? In a heartbeat. Memories like the corners of my mind, misty watercolor memories of the way we were, scattered pictures of the smiles we left behind, smiles we gave to one another, for the way we were. Can it be that it was all so simple then? Or has time rewritten every line? If we had the chance to do it all again, tell me, would we? Could we? Memories may be beautiful and yet what's too painful to remember, we simply choose to forget. So it's the laughter we will remember. Whenever we remember. I'm off to find a real supernatural biofilm, right when you get work. Hey, do you think that my time warp was actually a case of time flying when you're having fun? I think so. This has been As the Ocean Churns.